Welcome to CS 1401 Video 15.2. In the previous video, I presented recursive pseudocode algorithms for summing the digits of an integer, for calculating the length of a string, for finding the last letter of a string, for collecting all the numbers in a string, and for removing the blanks from a string. In this video, I'll present Java implementations of these algorithms. I'll start with the algorithm SumDigits. Here's the recursive pseudocode algorithm I presented in the previous video. The algorithm takes a single argument that's an integer. If that integer, the number, is less than 10, well, I've got a single digit, so I'll just return the number. Else, I'll return the least significant digit, which I can get by the number mod 10, plus the sum of all the digits to the left, which I can get by doing integer division by 10. The Java implementation of SumDigits follows the pseudocode algorithm directly. The method SumDigits takes an integer argument, the number whose digits the method will sum, and returns an integer, the sum of the digits. If the number is less than 10, then we're at the last digit and we can just return the digit. That's the base case. In the recursive case, the method will return the value of the last digit, that's the number mod 10, plus the sum of all the digits to the left, which the method obtains by calling SumDigits on the digits to the left. It does so by using integer division by 10. I wrote main as a driver for SumDigits. It parses the command line argument as an integer, checks to make sure the integer is non-negative, and prints out the result returned by calling SumDigits. So let's compile and test SumDigits. The first thing I'll do is compile SumDigits, and then I'll run it with a series of test values. And I'll start with an invalid input, say -1. And sure enough, our program correctly returns that it's not a valid input. So now we'll test it with 0. And that's correct, because if I sum the digits, it's not going to be any of 0. There are no digits to sum. With a single digit, and that's correct. I'll try it with a 2-digit number, say 47. 4 and 7 is 11, that's right. And now I'll try it with our original example, 315, 3 digits, and I get back the correct value, 9. The next algorithm I'll implement in Java will be string length. Here's the recursive pseudocode algorithm. The algorithm takes a single argument of type string called the string. If the string is empty, I return 0 because an empty string has no characters in it. Otherwise, I'll return 1, that's for the head of the string, plus the length of the tail of the string. This algorithm calls the function tail, so I'll start my Java implementation by writing a method for tail. It turns out that Java has a built-in method for the string data type called substring. When called with a single argument n, substring returns the string starting with the character n. Remember that the first character in a string will be character 0, so calling the string.substring of 1 returns a string that contains all the characters starting with character 1, that is, the second character in the string, through the end of the string. For example, quote, CS 1401 substring of 1 would return, quote, S1401. Lucky for us, this is exactly the behavior we want for our tail method, so I'll define tail as returning the string returned by substring of 1. Okay, I've defined our tail method, so now I can define the string length method, which tracks the pseudocode algorithm directly. The method takes a string, the string, as its argument, and returns an integer representing the length of the string. If the string is empty, then its length is 0. That's the base case. If the string is not empty, then its length is 1 for the character at the head of the string, plus the length of the rest of the string. That's the recursive case. To run string length, I wrote main as a really simple driver that returns the result of calling string length on the command line argument. Now that we have our Java program for string length, I'll compile and test it. I'll compile string length, and then I'll run it with a series of test cases that will check conditions in which we're interested. So first, let's check it with the empty string, and it properly says that the empty string has length 0. Let's check it with a string of length 1. That's right. Now we'll check it with a string of length 2. That's right. Let's check it where we throw in a blank just to see if it louses up our results. No, that's right, it's 3 characters. And then let's try it with a longer string like CS1401. And we get the right result. The algorithm for last letter is similar to that for string length, except that it returns a string with 1 character in it rather than an integer. Here's the recursive pseudocode algorithm from video 15.1. Last letter takes a single argument of type string called the string. If the length of the string is 1, well, then we're at the last letter, so I'll return the head of the string. That's the last letter, and that will be our base case. In the recursive case, I'll return the last letter of the tail of the string. Note that in addition to tail, this algorithm also uses the function head, so I'll have to define head when I implement last letter in Java. Okay, let's do that. First, here's the method tail again. It's exactly the same method as in the last program. What's new is the method head. Head also is implemented with the string method substring. In this case, with 2 arguments, substring returns a string starting at the first argument and ending before the second argument. So here, substring 01 returns the string starting with the character 0 and ending before character 1, which means it returns the string with exactly 1 character, character 0, which is the first character in the original string. And that's exactly the behavior we want for the method head. So now I can write the method last letter. If the length of the string is 1, then we have the last letter and can return it. That's the base case. Otherwise, the length of the string is greater than 1, so we'll return the last letter of the tail of the string. That's the recursive case. The main driver checks to make sure that there's at least 1 letter in the string. Otherwise, the last letter method could recurse forever. If the argument is a valid string, then main prints out the string returned by last letter. Now that we have the Java program for last letter, I'll compile and test it. I'll compile last letter, and I'll run it with a series of test cases that will check various conditions. So first, let's test it with the empty string, and it properly reports that it's a 0 length string, so there is no last letter. Let's try it with a single character. That works. With 2 characters. That's right. And now maybe a more complex string like CS1401. And the last character in CS1401 is in fact a 1. So it works. The next recursive algorithm to implement is collect nums, which, given a string, returns a string with the numeric characters in that string. For example, collect nums of CS1401 and CS2401 would return 14012401. Here's the recursive pseudocode algorithm. Collect nums takes a single string argument called the string. If that string is empty, then I'm going to return the empty string because there are no numbers in the empty string. Else, if the head of the string is a number, then I'll return the head followed by all the numbers in the tail, which I can get by calling collect nums on the tail of the string. Or if the head of the string is not a number, then I'll simply return collect nums on the tail of the string. This algorithm too uses the head and tail functions, so my Java implementation will have to include them. I'll also need a method to determine whether a character is a number. I'll call that isNumber. So here's my Java program for collect nums. First, I'll define a Boolean method called isNumber. This method takes a string that contains a single character and returns true if that character is a numeric digit. My approach is to use Java's built-in string method contains. If the string of the 10 numeric digits from 0 to 9 contains the character in its argument, then that character has to be one of the digits and the method will return true. Otherwise, it will return false. I've already defined head and tail, so now I can define the collect nums method. If the string is empty, there aren't any more numbers to collect, so I can return the empty string. That's the base case. There are two recursive cases. If the head of the string is a number, then the method returns the head plus all the numbers in the tail of the string. If the head of the string isn't a number, then the numbers in the entire string will be whatever numbers are in the tail of the string, so I'll return the numbers in the tail of the string. Now I can compile and test collect nums. I'll compile collect nums, and then I'll run it with a series of test cases that will check different conditions. So let's first check an empty string. That's right. Then let's check a string with no numbers in it at all. Now let's check it with a string with a couple of numbers in it. And that works. And now let's check it with a longer string with a bunch of numbers in it. And we get back exactly what we expected. Finally, let's look at the recursive pseudocode algorithm for remove blanks. Remember that this algorithm takes a string argument and returns an equivalent string minus all of its blanks. So remove blanks of, quote, CS1401 and CS2401 would return CS1401 and CS2401. Here's the pseudocode algorithm. Remove blanks takes a single argument of type string called the string. If the string is empty, then I return the empty string because it has no blanks in it. Else, if the head of the string is a blank, then I'm just going to return the tail of the string with the blanks removed from it. If the head of the string is not a blank, then I'll return the head of the string plus the tail of the string with the blanks removed from it. I note that I'll need a method isBlank that returns true if and only if its argument is a string containing a single blank character. All set? Let's look at the Java implementation. I'll start by defining the method isBlank, which is pretty simple. The method returns the result of testing whether its string argument is equal to a string containing a single blank character. Next, let's look at the remove blanks method, which directly tracks its pseudocode definition. If the string is empty, there are no more blanks to remove, and we can return the empty string. That's our base case. If the string isn't empty, then our first character in the string is either a blank or it isn't a blank. If it is a blank, then just return the result of applying remove blanks to the tail of the string. If the first character isn't a blank, then return a string with that character followed by the result of removing the blanks from the rest of the string. Those are the two recursive cases. The main driver simply prints the result of calling remove blanks on the command line argument. And I've already talked about head and tail, so we're ready to compile and test the Java program for remove blanks. I'll compile remove blanks, and I'll run it with a series of test cases, starting with the empty string. And that's right. Now I'll try it with a string that just has a blank in it. That's right. Now let's try it with a string that just has one non-blank character. That's correct. How about a string with two non-blank characters and a blank in the middle? That's right. And now a longer string. And we get back exactly what we expected. Well, that's a look at implementing some interesting and useful recursive algorithms in Java. In the next set of videos, I'll start exploring the concept and practice of object-oriented programming. See you then.